Hello everyone. Let's provide the solution to 8 to the power of x plus 2 to the power of x equals 68. Okay, so our first target is to break this 8 into simpler form. So we have 2 to the power of 3, then multiply by x. Because 2 to the power of 3 will give us 8. Now we have 2 to the power of x to be equal to 68. Now from here, we can rearrange what we have here. So we get 2 to the power of x, then to the power of 3 plus 2 to the power of x equals 68. What do we do from here? From here, we can see that 2 to the power of x is appearing in two places. So we can write that as y to the power of 3 plus y is equal to 68. And this means that y is equal to 2 to the power of x. So we have y to the power of 3 plus y equals 68 to deal with. How do we solve this problem? Okay, so the next thing on our mind is to factorize what we have here. But I'm going to write this in the form of this. So I'll write y to the power of 3 plus y to be equal to 68 is 64 plus 4. Okay, so y to the power of 3 plus y is equal to 4 to the power of 3 plus 4. Now, compare what we have on the left and on the right hand side. You can see that they are almost the same thing. And you will also see that our y is equal to 4. But then we are not getting only the real solution. We'll get the complex solutions. So we write y to the power of 3 minus 4 to the power of 3. Then we have plus y minus 4. Everything is equal to 0. This will be dealt with separately. Okay. Remember, if you have a to the power of 3 minus b to the power of 3, this is the same thing as a minus b into a squared plus ab plus b squared. So I'm going to write this in this form. So a minus b becomes y minus 4. Then a squared, that is y squared, plus ab, that will be y times 4, and it's 4y. Then plus b squared, which will be 4 squared, and it is 16. Close that. Then plus, open bracket, y minus 4. Everything is equal to 0. From here, we have something common. Y minus 4 is here, y minus 4 is there. So I'll bring out y minus 4 as a common factor. Then here I'll have y squared plus 4y plus 16. Okay, then we have plus this divided by this will give 1 over here. Then we equate to 0. Now y minus 4 is a factor. Then y squared plus 4y plus 17 is another factor, because 16 plus 1 is 17. Now we have two factors to multiply in order to get 0. Therefore, one of them or both of them must be equal to 0. So if y minus 4 is equal to 0, then y is equal to 0 plus 4, and then y is equal to 4. But mind you, when we say that y is equal to 2 to the power of x, so 2 to the power of x is equal to 4, and 4 is 2 to the power of 2. Now the bases are the same, so that our y, our x will be equal to 2. So we have this already as the real solution to the problem. But then we are to get the other solutions, as many as possible. So we'll go back to this quadratic equation, which is y squared plus 4y plus 17 equals 0. We are going to use the formula y is minus b plus or minus b squared minus 4ac. Everything is over 2 times a. This is the quadratic general formula. So y now will be minus b becomes minus 4. So I'll write minus 4 over here. Then plus or minus b squared, that will still be 4 squared. Then minus 4 times 1, because a is 1, times c, our c is 17. Right? Let's go over that again. Our a is 1, our b is 4, and our c is 17. So we divide this by 2 times 1, which will still give us 2. So y now will be minus 4 plus or minus 4 squared is 16 minus 4 times 1 times 17. That will give us 68. So we write 68 over there. Then we divide this by 2. Okay, so meaning that y is equal to minus 4 plus or minus square root of negative 52. Then we divide by 2. Y now is minus 4 plus or minus square root of 52 multiplied by square root of negative 1 divided by 2. What I did is bringing out to bring out the negative from here, so that we'll place it over here. If you multiply these two together, it will give us square root of minus 52. Now from here, let's simplify root 52. Y is equal to negative 4 plus or minus square root of 4 times 13, because 4 times 13 is 52. Then we multiply by root 1. Everything is over 2. Now y is minus 4 plus or minus square root of 4 is 2. Then we have root 13 multiplied by I. Square root of negative 1 is imaginary, so we write I. Then we divide by 2. Y is minus 4 over 2 plus or minus, we have 2 root 13 I over 2. Mind you, this I is not under the square root. 2 will go there, so that y is equal to negative 2 plus or minus 2 will go there, and I want to write I first. So we write I root 13. Okay, so from here now we can say that y is equal to minus 2 plus I root 13, or minus 2 minus I root 13. So these are the two solutions from the quadratic equation, and these two solutions are complex solution, and that is why we have the I in the solution. But the only real solution is the one we got before, which is y equals 2, which is y equals 4, and it later gave us x to be equal to 2. By the way, we don't have x. We do not have x, y in the equation given, so we will still convert this. Okay, let's go back there. When y is 4, x is 2. Now this means that y itself is 2 to the power of x, and this is equal to negative 2 plus I root 13. What I'm doing is to work with the first value of y, which is this. So from here now, we take the log of both sides, so that x log 2, because the power here will always go behind, x log 2 is equal to log of open bracket minus 2 plus I root 13, right? So to get the value of x, we'll divide this by log 2, then divide this by log 2. This is going with this. So our x is now log of minus 2 plus I root 13 all over log 2, right? This is one of the solutions. And the other solution, if I let's call this x2. Now, the last solution now is when our value of y here is negative. So we'll now have log of minus 2 minus I root 13, then divided by log 2. So we now have the two solutions, which are complex solution, and the only real solution, which is x, which is x equals 2. Thank you for watching.